And now you can run, so I have different algorithms available, so we are about to try them all. It's interesting, I think, for everyone, even for me. I don't know if it's working on this one specifically. We added recently some smart selection tools. So let's start with this one, the select small part. I'm just about to do a quick saving here if we need to go back at this specific step later. So yeah, so the save in PiXYZ format is very quick and can save you a lot of time if you want to go back. Since unfortunately we still do not have any undo function, it's definitely a high priority in the roadmap. But so saving is also a good option. So let's use the selection tool, select small part. This one is based on geometrical properties. It will scan the model and try to select parts based on their bounding box dimension. So bounding box is the global size of your part. So for these small screws here, it will be a little box around the size of the screw. You can define the maximum size for your boxes. So let's try 100 here of diameter and run the algo. So I've definitely selected all the parts, but maybe more than I would like. I have the small screws selected, but also these other features. So let's try to run again the selection with a lower value. Okay. Once again, maybe a little too high, but I still have my screws. Let's try one more time and we'll stay with this one. Let's say 25. Okay, perfect. So here I have selected all the small unitary nuts and screws. These are altogether, there are around 86,000 polygons out of my 1.3 million. So almost 100. It's, let's say, roughly 5 or 7% of the model. But I have a lot of other elements. I have only isolated this one, but you have also screws here, here, and all around the model. So you can imagine if you apply the same process to the entire model, you could save a lot of polygons. And two different techniques to handle these screws. You can either hide them or remove them from the geometry. So this is really depending on your use case and what your client or customer want to do in Unity. You can apply on this one a different decimation setting. So for example, here I can reuse the decimation function and use the strong setting instead of the low. So having a lower quality, but reducing more the number of polygons. And I will use another technique, which is still in reduce mesh, but which is replace by box. This is, I would say, the last level of the decimation. It's replacing all these elements by their bounding box, by small cubes. So a primitive composed of, if I'm not saying something stupid, 4, 5, 6, 12 polygons. And I'm going to replace by a box all these small elements. A box that can be oriented. Here it is. So here I have created small boxes to replace all these small nuts. And the number of polygons dropped down from, what was the number, 86, I think, thousand to 3,000. So we divided by the number by something like 30. So we keep the information of small elements available here, but if you are looking to the object from far distance, you won't see the difference between a detailed screw and these small boxes. And if you don't need them, just delete them or put them in the no-show. So this is a solution to automatically identify small elements, select them using the smart selection tools, and afterward reduce them in a different manner than the rest of the model. Okay, so now we have a model which could be, oh, maybe I can, we have more occurrences than we had at the beginning. That's because I exploded completely this element here. So now that I have processed my small cubes here, I can go back to the original hierarchy with a lower number of occurrences. And what I will use is, because here is what happened, here is this entity, it's this one. And here we have all these parts I have exploded. What we want to do here is to keep the same hierarchy, but merge together all these elements here. So I could, of course, select this one all one by one, but it's not the best way.